Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Can everyone hear me okay? Are we ready to go? Okay. So I'm Anit Thakkar. I'm a research scientist at the Johns Hopkins University. And I'm going to be talking about this batch query workbench service. It's a .NET service called CasJobs that we've developed. And it's got a personal user database, a SQL Server database called MyDB. And so I'll also talk about where we're heading towards this. And we're going to be going towards distributed asynchronous web services. So this is the cast of characters at JHU that have contributed to the development of this. And of course, ably assisted and guided by Jim Gray. He warned us to stay away from databases, but we didn't listen. And now it's too late. And the data we're accessing is the data from the Sloan Digital Sky Survey, which I'll describe in a moment. And this all is happening in the larger context of the Virtual Observatory movement. The National Virtual Observatory is the US part of the International Virtual Observatory. Whoops. And there's an International Virtual Observatory Alliance, which is developing standards for so that different virtual observatory services can talk to each other. And we aim to conform to most or all of these standards. So here's a brief outline. I'll give a brief introduction to the Sloan Digital Sky Survey and the main web access to it, the Sky Server. And then I'll say why we needed to develop this CasJobs service, give a brief overview of it. Actually, the demo, if I have time at the end, I'll defer it to the end, and then describe the impact that CasJobs has had on our workload management and services, and then where we're heading with CasJobs in the future. So the Sloan Digital Sky Survey is this project to develop a map of a large part of the northern sky, about covering a quarter of the whole sky, 10,000 square degrees. And it's going to create a digital map in 5 spectral bands, so 5 different wavelengths. And it's by the time it's finished, it's almost done. It's expected to have close to 40 terabytes of raw pixel data, and the photometric catalog is going to hold about 200 million objects. Actually, we've already reached that. It's going to be more than that now by the time it's finished. And we're going to have spectroscopic data on about 1 million objects. So the latest public data release, which occurred at the end of June, was data release 4, which has 180 million images of astronomical objects and about 600K spectra. Here's a timeline of the public data releases that we've had to date, starting in 2001, June, with the early data release, and going on up to DR4, which happened this June. And so, as you can see, the data size has been increasing. We've got about 4 terabytes of data released with the latest public release. And there are mirrors worldwide of the previous data releases. So there are 2 main components to this Sloan data. There is the data archive server, which gives you access to the raw pixel data. And this is basically a file-based access. And you can get image, spectra, et cetera, and through some fairly low-tech tools. And then there is the catalog archive server, which is a SQL Server database server, and it's heavily optimized index for fast access and data mining. And this is the URL for the main SDSS site. And then you can use either of these 2 URLs for the Sky Server, which is the access to the catalog data. So what does the Sky Server provide? It provides several levels of web-based, browser-based access, ranging from novice, casual users, members of the public, to expert astronomers who are using it for serious research. And there are also visual tools such as finding charts and navigation tools to browse through images and image lists, and to examine each astronomical object individually. There's an explore tool. And then there are downloadable interfaces as well. So, and then we keep extensive logs of all our traffic on the Sky server site. And that's basically what's helped us manage the workload and told us that we should develop CasJobs. So as it is in the database, we've got several performance features built in. One of the main things that we added was this hierarchical triangular mesh of multidimensional spatial index. And this is actually publicly available code that you can plug into your own database if you want, and several people have done that. And of course, there are lots of database indices. We've also extracted the most popular parameters from the largest table, which is almost a terabyte now, and put it into this thin table called, did that again, the photo tag table. And we've got some pre-computed joins to speed things up. We've also spread the data over several disk volumes for faster access. But in spite of that, as the size of the data has increased, we've noticed that there's a lot of delays and slowdowns in the query response. And what we saw when we looked at our Sky server traffic logs was that the query execution times follow a power law. So most of the queries are very fast, less than a minute, considerably less than a minute. And then, so there's a whole lot of queries in this quick part of this chart, and then there's a power law fall off for all the other queries, and there's a few queries that take a long time and slow down the whole system. So what that told us is that we should separate the short and the long queries. And so for the long queries, we also wanted to limit how many were executed concurrently. So we wanted to execute them in some sort of batch mode. And we want to strictly limit the time, for execution time for the longer queries. The other thing we noticed is that there was a lot of unnecessary downloading of user query results when people were refining their queries. So they needed some intermediate space, local space, where they could put their query results and not have bottlenecks on the network. And this also allowed sharing of query results between collaborators. So we've also seen over the last couple of years that the SQL use has been increasing. As I said, the Sky server provides several levels of tools for accessing the data. There are several form-based tools which don't require you to use SQL. But we found that most people, after using these tools, find that they're not enough for some of the more complex things they need to do, and then they start using SQL. There's a lot of help on our site as well, and there's about 40 or 45 sample queries that they can use to learn SQL. So this also meant that we needed to provide a really competent tool for them to submit SQL queries. So that's what gave rise to CasJobs and the MyDB database. So this is a batch query workbench service. And the name CasJobs comes from the fact that it provides access to the catalog archive server, which is the part of the data that's stuffed into the databases. So the queries are queued for batch execution, and this provides load balancing. We execute batch queries in batch mode on more than one server, multiple servers. And this is done via linked servers in SQL Server. And at the moment, we limit 2 simultaneous batch queries per server. so that each of these queries can last for hours, and they can slow down the system significantly, so you don't want more than a few running at a time. And then the short queries are basically, right now, limited to a minute. And most things actually do take less than a minute. And so there's the short, and then the long queue is up to 8 hours. If you can't do your query in 8 hours, if it doesn't complete, then most likely you're doing something wrong. So this MyDB personal database, we started off with half a gig. Now we've got a 1 gig per user, and we're pretty generous about giving more space to users if they need for specific queries. So the long queries in the batch queue write to the MyDB by default. So there's no downloading of large query results to your client. And then you can define groups to share your MyDB tables. Recently, we've also, this is not up on the production version yet, but we've added query estimation. So the SQL query plan, actually, there's a graphical display of that. And there's plotting and XML output as well. So here's a quick view of the MyDB features. You can look at your tables, views, functions, procedures. You can extract and publish your tables. Of course, create and drop stored procedures, functions, and rename your tables, etc. This is how the job management is done. It's asynchronous, and it separates the actual execution of the query from the extraction of the output. So those are separate jobs, and they are all handled in the same queue. And there's a batch admin database that keeps track of job servers, etc. So this is how we provide state in the web service. This is what a typical display of your history or job, your own personal job history looks like. So how is it actually implemented? So it's a set of SOAP XML web services. And we found that it works OK for multi-gigabyte transfers. You can access this via any SOAP toolkit. And there have been Java, Python, and Perl tools to access the CasJobs and MyDB. There's also a command line interface to CasJobs. So as I said, it's stateless and asynchronous, but the state is provided by the database, the admin database. We also keep all the user information in this admin database. And generally, this is a distributed SQL Server framework where the batch admin is on one server, and then the actual query gets executed on other servers. That also provides load balancing.
For the multi-gigabyte transfers, are you using SOAP with attachments or line?
It's SOAP with attachments, but there aren't, I don't think we've, so do you mean like binary?
Yes.
We don't have that as yet.
You're presumably not doing like we used to or some kind of XML encoding on the data, right? Data gets streamed to
Say that again.
The attachment basically gets streamed to standard TCP stream encodings, right?
I don't think we have attachments right now. Oh, it's an ASCII. Yeah. These are ASCII tables.
The point is that you're not paying XML and SOAP overhead just for message.
Right.
Not for the gigabytes.
Yes.
Gigabytes go across at gigabytes.
Yes.
With no.
Sorry, I thought you were talking about binary. Yeah.
So the cost of sending one of these attachments with SOAP is relatively high because you're amortizing sort of big header over big piece of data.
Right. Okay, so let's see. Looking at how CasJobs has helped. So this is a look at the monthly query traffic over the last couple of years. And so we've seen an increase in the number of queries, which is the actual histogram. by about a factor of 10. Over the same period, the data size has increased by a factor of 10. So we're going from 100 gig to about a terabyte. And so the workload has actually increased by a factor of 100. And in spite of all that, the average elapsed time has improved by roughly about a factor of 10. And we're making better use of the CPU. So we're still quite I/O bound, but not as much anymore. So this is another way to look at it. So CasJobs use has increased by about a factor of 100, and the CPU utilization has increased by about a factor of 10, from 1% to about 10%. And as I said, because of the MyDB and not downloading your results as often, we are less I/O bound than before. The fraction of the CPU utilization has increased. And as far as the user community goes, we find that there's a large community of users using this CasJobs, and many of them submit several hundred jobs, and the total number of jobs is a few thousand per month. And so this has also helped to increase the SQL proficiency among the user community. And basically, people prefer to use this tool rather than the browser-based SQL access. So where do we plan to go with this now? So the big question is, right now we have about 2 or 3 terabytes of data in the current SDSS data releases. How do we scale CasJobs up to the next level when we get, by the end of the decade, to surveys like the LSST, the Large Synoptic Survey Telescope, which will be doing one SDSS every 2 or 3 nights. So we need to think about how to do that, and also how to integrate CasJobs with the other VO services that we have currently, such as the federated cross-matching service, OpenSky Query. And then how do we make CasJobs and the MyDB part of it distributed in general? Like, how do we provide access in a distributed environment to a personal database? So as far as scalable data access is concerned, we're basically looking at horizontally partitioning the data across a cluster of SQL Server nodes, providing parallel access to the data. And this is done using declination zones, which is something that Jim and Alex developed. And it's a quick way to do spatial decomposition. It's sort of a poor man's HTM, if you will, hierarchical triangular mesh. And so we want to go further and basically do the data partitioning when we ingest the data, when we put the data into the databases in the future. But right now, we're working on this. There's a poster on this project here to do large-scale cross-matching. This is a project funded by a Microsoft research grant, and Maria Nieto Santisteban at Hopkins is the PI on it. So this is basically to do cross-matches on a large scale so as to scale OpenSky Query to large all-sky cross-matches, to several billion object cross-matches. And here's a quick look at a partitioning benchmark that we did last year, just how the partitioning of the data has helped. And we took a file-based, file grid-based application that found clusters in the SDSS data, and compared the file-based application with the SQL Server partition application. Sorry, that's this side. And it gave us a fairly consistent speed-up factor of about 50 times. And the main trick here is that we were doing the analysis right in the database, and we were only getting the data that we needed, whereas in the file base, they had to get the whole file and then extract whatever data they needed. So extending this partitioning for the cross-match, this is basically a cartoon of what you would do in order to. So these are the declination zones. And if you wanted to do this type of cross-match, you basically would consider the zones that are in the intersection. And the test that Maria has recently done is the entire SDSS DR3, data release 3, with 2MAS, which is a all-sky survey, 2-micron all-sky survey, but it's not as deep as the SDSS, and USNO, U.S. Naval Observatory survey, which is this footprint here. So here's a quick look at the zone distribution. Now, I'm not sure why there are spikes in the zone distribution. I think they're still trying to figure that out. Maybe Jim knows. Something that we need to look at. But this is how the zones are distributed for the USNO data, the SDSS data, and then the 2MAS data. And the partitions, how they are distributed among the 3 databases that are being cross-matched. So this is just the objects that are involved in the cross-match. And then the time performance. So for the number of servers, how do the CPU hours and the total elapsed time scale, and it's a power law fall off in each of these. And so it's looking pretty good. And the I/O performance is also a lot better, as expected with the number of servers. This is the physical disk I/O in terms of gigabytes, and then the disk I/O time. So each point represents 2 different quantities. So distributed CasJobs. We want to integrate this with OpenSky Query, because a lot of people have already asked us for functionality from one in the other application. So if OpenSky Query currently provides you with the ability to upload your own table and cross-match it with an existing database that's listed in the OpenSky Query menu. And of course, people want to do that with CasJobs because they can submit very sophisticated queries and get the results to their own database. So there's a natural need for integrating the 2. So I'll briefly describe OpenSky Query. It's this IVOA, the International Virtual Observatory Alliance compliant version of Sky Query, which was an original .NET application that won a second prize in a .NET contest a few years ago. So we want to incorporate this large-scale cross-match engine into OpenSky Query, and then combine it with CasJobs. And then we want to go further and implement the IVOA standards, emerging standards, such as VoStore, Virtual Observatory Store, and Virtual Observatory Space. VoSpace is a way to provide distributed access to VoStores and provide the security, etc. So the CasJobs MyDB will be a type of VoStore. And of course, we will need some kind of single sign-on security mechanism. And the way to bring all this together will be with distributed asynchronous web services. And so there are proposals right now on the IVOA Twiki for how to do this, basically how to incorporate asynchronous activity in web services. So just a quick word about OpenSky Query. So it started out as this .NET prototype application, Sky Query, where we have these archives that we call Sky nodes that are distributed anywhere. Like we had several distributed across the US. Then there's a portal, a .NET portal, that lets you submit queries to this distributed system of archives. And this is how the Sky Query execution works. Basically, what we do is first we find out which is the smallest footprint or smallest cross-match among the various archives. And then we start with that, so that reduces our workload right off the bat, and then recursively go to the next Sky nodes in the list. And then we go on to OpenSky Query, which then extends Sky Query towards to incorporate the IVOA standards. And so now it's become a sort of standard in the VO community. And we have Sky nodes being developed by third parties, other archive sites all the time. So as far as asynchronous web services are concerned, as I said, there is this IVOA asynchronous activity proposal, and it includes proposals on how to query large data sets, how to do large-scale cross-matches, and then in general batch processing for data mining, and even complex workflows. And so it also incorporates emerging web service standards, which are supported by all the right players. And it's a way of going from stateless to web services with some state information. And so we will be basically looking at where the IVOA is headed and incorporate these standards into the future of CasJobs. So the distributed VoStore, this is basically how they will work. The user comes in at the top with some sort of, there's this community VO service that acts as a certificate authority and lets the user sign on in one place. And then the user can go and have access to distributed data stores, such as CasJobs, MyDB, and other things, including file-based stores like SRB. So basically, the VoSpace provides a layer on top of the VO stores to provide distributed access and security. And so we leave the authentication up to the individual services, so they can decide whether a user is actually authorized. I'm sorry, this should be authorization. Authentication is actually at this level. And the services also have their own interfaces for giving access to their local users. So CasJobs MyDB right now provides a fairly versatile query workbench facility. But in order to move further with it and incorporate it into the virtual observatory community, and also to give more functionality to SDSS users, we want to integrate it with OpenSky Query, which will give it a federated archive access and also give it the ability to do large-scale cross-matches. And then we want to move towards distributed asynchronous services in the longer-term future, so as to scale to large distributed data sets and provide distributed access and security, of course. So I don't know, do I have a couple of minutes or 1 minute? Okay. Let me just directly go to the test site, which is cooler. So here's what the main query screen in CasJobs looks like. So I can type in a query here. Oh, I shouldn't have. Okay, there are a bunch of contexts here which you can select from. You can select your own personal database. You can select this SDSS DR3 version here. If you're an admin user, you can also look at the batch admin database. And then there's some test, and then this is an older version of the SDSS data, DR2. So let me select DR3, and I can do a syntax check. It says syntax OK over here. Look at the query plan. This is a sort of graphical look at the SQL query plan. Pretty neat. This is something that's been done by Nolan Lee, who's the main CasJobs developer we have at Hopkins. And then you can either submit it in quick or in the long query mode. you can hide your query in order if you wanted to look at your results. So let's submit it. This is a quick query, so it should come right back. And here are the results. So, and then you can plot them. That may take a few seconds. You can save them as either as HTML and CSV format. There's a VO table, which is the standard virtual observatory format, or as a data set, an XML data set. This is, again, a VO table plotting package. That's a virtual observatory standard. And then you can select what you want to plot, etc. Plot a histogram. This doesn't make any sense with this data. Anyway, what I want to show you quickly is the job history page. So if I want to look at all the history, as you can see, most of my queries failed. Go to the MyDB page. Here you can look at, see, your My Tables. By default, it calls it My Table and then appends a number to it. Or you can rename it, call it something else. So you can view the data, the first, let's say the first 100 rows. Look at the query. Right now it says not, this is an old table, so it cannot find the query for it. You can plot it here as well. Download results. Do neighbor searches. Look for neighboring objects. Publish your table. Rename it, of course, and drop. So all these things you can do from your MyDB screen. Then you can have groups. You can invite people. You can create a group and invite someone to join your group. Here's a few members in a group that test group that I define. And then here's the output screen. Here's where the pending output, etc. And you can extract it in whichever format you want. And we've got this help page that I wanted to show you some of the advanced CasJobs queries. So people can do some fairly complex stuff, including defining temporary tables and using them in their queries. So there's a fair bit of help available. Plus, they can also look at all the Sky server sample queries and cut and paste those and run them here. Anyway, thank you very much. Yeah. I don't think we have a very accurate sense of that because the people who actually email the help desk are the more advanced users usually. And of course, the sample queries work as right off the bat, so you won't hear from those people. We haven't looked at the logs to see how many of them. I mean, the sample queries by themselves are not very useful. I mean, they don't, everybody doesn't want the same type of objects, or everybody doesn't want to do the same things with their objects. So they give you a good idea of how you would do it, but by themselves. And plus, most of the sample queries, we've got a top 10 or top 100 on them, just so that they don't take very long when users will inevitably just cut and paste them. So.
I guess this question is related to what I'm wondering about. What fraction of the astronomy community can use this, given that they have to sort of use the SQL? In other words, do you feel there's a need for another layer above this that would sort of try and hide that, or is that something that's not really that critical?
So in the Sky server, we've got layers to hide that. We've got some fairly, everything from just a 1 or 2 line form to a very complex form-based query. And we find that, after using those for a few times, and people eventually go on to the SQL. But even in OpenSky Query now, there have been people asking, can we have some sort of a graphical query construction? And we've got one tool, a query builder tool in there. But they want some more sort of simple form-based query construction. So, yeah, there is a subset of users always asking for that. And we don't have that I mean, CasJobs, basically, we sell that as the advanced tool for people.